In this video, we will compute the mean and the standard deviation by hand. The mean for the sample and the population is computed the same way. However, the standard deviation for the population is slightly different than the standard deviation for the sample. Part A. Normal dice have 6 faces. Each face corresponds to a number between 1 and 6. Suppose we select only 4 numbers from the list 1, 2, 3, 4, 5, 6 from a 6-faced die. Compute the mean, variance, and standard deviation of the numbers 1, 2, 3, 4. In this case, only 1, 2, 3, 4. Since 1, 2, 3, 4 comes from 1, 2, 3, 4, 5, 6, we assume that this is a sample. And so we will compute the mean for the sample, the variance for the sample, and the standard deviation for the sample. There are 4 numbers in this list, and so x1 is 1, x2 is 2, x3 is 3, and x4 is 4. Those are the values from the sample. The mean x bar is computed by adding all these values, 1 plus 2 plus 3 plus 4, and take the sum divided by the count, which is n. 1 plus 2 plus 3 plus 4 is 10, and the count is 4 because there are 4 numbers from the list here, and this is 2.5. So the mean of the sample is 2.5. Now the variance. The variance is denoted as square, and it is computed using the sum of all of the deviation squared divided by n minus 1 for the sample. So this is the variance for the sample only. The deviation is the x value, each x value minus the mean of the sample. In this case, there are 4 terms in this sum. The first term is 1 minus 2.5. That is the first deviation. We square this. Plus, the second deviation is 2 minus 2.5, and we square this. The third deviation is 3 minus 2.5 squared. And the last deviation is 4 minus 2.5 squared. And we would divide it by n minus 1. N in this case is 4 because there are 4 numbers, and n minus 1 is 3. The sum in the numerator is 5, then we divide it by 3. This is the variance. There's no need to use the decimal here because the number is quite small. The standard deviation of the sample is the square root of the variance, and it is denoted s. And so s equals the square root of s squared. But we compute s squared, which is the variance. It is 5 over 3. The square root of 5 over 3 is 1.29, rounded to 2 decimal places. And so we found the mean, the variance, and the standard deviation of the sample because 1, 2, 3, 4 comes from 1, 2, 3, 4, 5, 6. Part B. Tetrahedral dice are shaped like a pyramid with 4 faces. Each face corresponds to a number between 1 and 4. Compute the mean, variance, and standard deviation of the numbers 1, 2, 3, 4 from a tetrahedral die. Now, in this case, there are only 4 numbers from this tetrahedral die. And so we treat 1, 2, 3, 4 as a population. Everything, 1, 2, 3, 4, from the 4-face die. To compute the mean, this time this is the mean of the population. It is computed the same way we computed earlier. 1 plus 2 plus 3 plus 4 divided by the count, which is 4. This is 10 over 4, or 2.5. The mean is still 2.5. The mean for the population is usually denoted using the Greek letter mu. It is pronounced mu. It is a Greek letter. To differentiate from the sample mean. The variance for the population is computed very similarly to the variance of the sample. We add up all of the deviation squared. The deviation is each of the x value minus the mean, but this time the mean is the mean of the population mu. We square this, but this time we divide it by n instead of n minus 1. This sum is 1 minus 2.5 square plus 2 minus 2.5 square plus 3 minus 2.5 square plus 4 minus 2.5 squared. But again, this time we divided by 4. The count is 4 instead of 3 that we did earlier. In the numerator, the sum of all the deviations squared is 5. It is the same numerator we got earlier, but this time we divided by 4. 5 divided by 4 is 1.25. The standard deviation of the population is the square root of the variance, which is the square root of 1.25. And the square root of 1.25 is 1.118. If we round it to 2 decimal places, it is 1.12. Notice that the standard deviation for the population in this case is a little bit smaller than the standard deviations of the sample because we divided by n instead of n minus 1. For the population, the mean is labeled mu, and for the standard deviation, the mean is labeled sigma. This is the Greek letter sigma.